Gotcha, you bug shit git. Wait. Oh, hold on. No. Fuck! Hello there. And welcome to the Antivirus Devlog. Sorry you had to see that. For those of you who follow my itch.io account or my Luke Coles Games Instagram account, you know this isn't technically my first game. The first game I released, in fact, was the Christmas game You're Late for Christmas. So Luke, I hear you ask, why didn't you also release a devlog video on that? Surely it would have got more people to try it. True, but then I realised just how much editing 30 days worth of dev time would take to do. And after the grueling rush to get the game out in time, and the fact that it was free, so I also had no financial incentive, I didn't want to. Hopefully this method of doing small bite-sized chunks of development at a time will be easier on me and drawing more attention. So, what am I making this time? Simple. The same thing that every indie game developer makes when they're first starting out, an arcade game. More specifically, a Space Invaders clone. However, there's a problem here. I've already made it. You see, a couple of years ago, after I'd finished my A-levels, I went to college to study games development. A lot of good those things did me in my adult life. Whilst I was there, during the summer break, we were tasked with completing some sort of project to submit that would contribute to our final grades. At least, that's what I thought. In reality, I never saw any feedback on it, so I assumed that we didn't actually have to do anything. Once again, I did not read the fine print and just create more work for myself. I was a dumb guy. Something that I'm afraid hasn't changed today. Anyway, the game I created was called Antivirus. It was a Space Invaders or Gallagher clone, depending on your interpretation, where you play as an antivirus software fighting against a series of computer viruses based on old nostalgic forms of software, bosses based on specific types of malware, all to the backdrop of iconic operating systems, such as this beautiful pixel art rendition of Bliss I made. Or this version of Aero. Yeah. Also, quick question, will I get in trouble for these designs? Please tell me quickly so I can change the logo design. I'm scared. You can't be too careful. As I was testing the game, I found myself thinking, this is really fun. Normally I would just give these sort of games one play and leave them alone, but I found myself playing this constantly. And so maybe, and I emphasise the word maybe, if I release this as a commercial project, it could be a small hit. But due to tax stuff and red tape I didn't want to deal with, I never did. The tax interview confuses me. Years later, I returned to Antivirus and decided, screw it, I'll release it. Only one problem. Can I seriously expect to charge people their hard-earned money for a game that looks like this? Nope. You all are much smarter than that. I know I can do better. With content cut from the original, more levels, more game modes, power-ups, enemies, bosses, player ships, and that's exactly what I intend to do. And I'm taking you all along for the ride this time. So without further ado, let's develop. Day 1. I booted up Godot and the first thing I did was basic project setup. Surely I could just copy the settings for the old version, right? Wrong. You see, when I made the game last, I created the sprites, then scaled them up in the engine. I didn't want to do that this time. Is this stupid? Probably. Am I too stubborn to just scale them and make the pixels on some sprites just look really big? Yes. I also set up the input map, binding keys for moving and shooting, as well as the power-up system I will tell you about later once I've actually made it. And finally, I set the texture filter to nearest. You see, when you import a pixelated texture into a game engine, the software usually likes to smooth it out to get rid of the pixels. Obviously, this is done so that more high-definition textures don't appear out of place or broken in high-definition 2D or 3D environments. Imagine if all the textures in something like the Resident Evil remake suddenly went back to their original PS1 counterparts, for example. But in this instance, I want it pixely. It's a pixel art game. So before I imported anything, I had to give the software strict instructions to leave my sprites alone. Now that that was over with, I created a new version of the AV1 sprite and imported it into Godot. From there, I created a starting ship with basic movement functionality. I say starting ship because in this version I intend to create more than one antivirus for the player to pilot. The player ship is a character body 2D node, which means I can use its built-in move and slide function to move it by just setting its velocity to a 2D coordinate direction multiplied by however fast I want it to move. Right now, all the code for the ship is inside the main script. However, this is only temporary, so I can get the player moving and check that the code all works. Later on in this devlog, I will show you how I changed this to a more readable format, at least for me. I prefer small scripts spread across the scene rather than a massive all-in-one script. I also used an animated sprite 2D for the player sprite, since I intend to add animations to the game, something else that the original didn't have. All the sprites in that version were static sprites. You'd be surprised by how much animated sprites can add to the experience. If I remember, I'll show you a before and after once I get some animations in. Finally, I created my first component. Now Luke, I hear you ask, what is this strange magic word that you just said? Well, young man or lady, sit down. Wait, if you're watching this then you're probably already sitting, so lay down I guess. Anyway, let me explain composition to the uninformed. So, what is composition? In game development, composition refers to the practice of building a game using smaller building blocks or components. Kinda like nerdy Lego. The code inside these components is designed to work with whatever they are dragged and dropped onto. Some examples of components could be a health component to calculate health reductions and tell the wider game when the actor it is attached to has lost all its health, or a move component that moves its connected actor through the game world. The first component I made, however, was a far simpler one, but a vital one at that. I call it the position clamp component. If you played a space shooter in an arcade before, you will notice that you can't move the ship outside the confines of the screen. Of course you can't, that would be stupid. You won't be able to see the ship and it could easily get it lost in the void. Therefore, my position clamp component does exactly what it says on the tin. Clamps a connected actor to the screen. More specifically, every frame it uses Godot's clamp function to keep the connected actor, in this example, the player, from passing beyond the border of the screen by locking its X and Y coordinates between them, allowing for some margin that I added so that half the sprite isn't allowed to escape. Also, look at this pretty little custom icon I made for it. I didn't know you could assign custom icons to your custom components and classes when they're in the scene tree, but I do now, and I am obsessed with it. I mean, I like visual stuff. We used visual scripting in college when we were using Unreal, and I'd say about half my development time was spent adding those colourful comment boxes to organise my code. I have eyes, I like colours. Day 2. Today I will create the ability for the player to shoot lasers. Can't really have a space shooter without shooting, so let's implement it. Firstly, I created a new scene for the player's laser, choosing the area 2D as its base node, imported the sprite, gave it a collision shape so it could tell when it hit something, and something called a visible on-screen notifier 2D that will tell the game when it leaves the screen so I can delete it later. If this wasn't there, and the player just endlessly shot lasers into the void, the amount of lasers in the game world would build and build until eventually the game has too much to keep track of and will crash. So yeah, don't forget to delete the lasers. I also expanded on my roster of components with these two, the spawn component and the move component. Beautiful. The spawn component obviously spawns things. I just have to tell it what scene I wanted to spawn, move the component into position, and when the spawn function is called, it instantiates, or spawns, it and adds it to the scene tree, making it appear on the screen. In this instance, the spawn function is run whenever the player presses the shoot button. The move component, obviously, makes things move. Specifically, it moves a connected actor in a set direction at a set speed, similar to how the player moves, just without any press buttons. Day 3. Now that the player could shoot, I had to impose a limit on how often the lasers spawn. Currently, the game checks every frame if the player is trying to shoot, therefore they can shoot huge numbers of lasers every second. This simply would not do. So to solve this, I added a small true or false, or boolean, variable called cooldown that only allows the shooting code to run if it's set to false. Now, every time that a player presses shoot, the cooldown is set to true and a timer starts. Once that timer finishes and emits its timeout signal, cooldown is set to false and the player is allowed to shoot again, significantly slowing the player's firing rate. Also, look at this firing animation. It's small, but it makes a difference. I like it. Moving on, there isn't anything for the player to shoot, so let's make some enemies. Here, I decided to follow another coding practice, classes. So once again, boys and girls, classes in session. So, what are classes in coding? Creating classes is the practice of creating templates for your code and creating subclasses with those classes. Confusing, I know, but think of it like this. Let's say you have a base class of car. This is the example usually used in Computer Science 101. Cars all have a few things in common. Wheels, engine, number of doors. So any class that inherits from the car class will have those variables. Let's create a subclass of car and call it lorry. Lorries have wheels, an engine, 2 doors, like the base class. However, something that lorries have but cars don't have is an enormous trailer attached to them. Cars obviously don't have that. Using this method, I could create a base enemy class and have all of my different types of enemies inherit from it. Currently, the base enemy class's script is empty, but once I add more components and functionality that each enemy would need, this will change. The main reason I did this now is for the lasers colliding with the enemies. Using classes, I only have to make the lasers check if they are colliding with something that inherits from the enemy class, rather than having to check every single enemy type to see if it's hitting one of them, cutting down on lots of lines of code. If you are inexperienced or not confident with implementing this yourself, you can do it the other way, but in my opinion, the more lines of code you can save without sacrificing readability, the better. Using the base enemy class, I created the first enemy type, the normal enemy. This is your basic enemy type you see in most Space Invaders clones. They start at the top of the screen and move down off the screen. The only way they can attack is kamikazeing into the player. Since the behaviour is so simple, it only requires a move component to implement it. I also created the ability to select a random sprite for the enemy to use. This means I don't have to create separate scenes for each version of the normal enemy, which I did in the last version of this game. Really done. Since the first level I have lots of normal enemies for variety's sake, I thought it best to make multiple sprites for it. Right, day 4. I've got player movement, shooting, enemy movement, and laser collisions. Now, it was time to create the health system. This required 2 more components, the health component and the stats component. The stats component simply holds all of the variables related to the connected entity's stats. In this instance, the actor's health and speed. However, this could be expanded upon in the future for different types of projects. For example, if I was making an RPG, I would add a variable for the player's mana, or if I was making an action game, I would add a stamina variable. This is why I believe in no base component supremacy. It saves so much coding time because you can just take the components you make in one game and slap them into another without much bodging. The health component, on the other hand, handles the actual calculations when the attached entity gains or loses health, and then fires a signal depending on whether it survives the attack or not. I then converted the code of the components that I had already made to use the stats component if they needed to, such as the move component, getting the speed from the stats component, set it all up, press play to test it, and it crashed. Everything was going so well, but as is inevitable in game development, I hit the first major bug. When I pressed play, I got this error message: invalid access to property or key speed. This error message was located in a normal enemy's move components node. This told me that the move component seemingly couldn't get the speed variable from the stats component, even though I told it that it exists and exactly where it was in the inspector tab. Yeah, weird, I know. But things were only going to get weirder. I decided to check if Godot knew that the stats component in a normal enemy scene tree existed by printing it out in the terminal. However, when it did, instead of just one print statement, I got 2. The second was the stats component, nothing wrong there. Godot knew all about it. But the first was null, as in Godot says there's nothing there. This told me that something else was activating the stats components code before I did. Now either my version of Godot is possessed by demons, or this is my fault because I have no talent. It was most likely the second, but I chose to believe in the first because it made me feel better about myself. And it wasn't until the next day that I realised what the bug was. In the background, the code in the move component's actual script was still running, meaning that it didn't have a stats component assigned to it and therefore couldn't run the movement code and crash the entire game even though I wasn't using it. Or at least, I thought that's what it was. Here's a tip for those using composition. If there's a bug with one of your components, make sure you remember to check all the scenes that have that component in them. You see, it wasn't some magical curse that was causing this crash. It was the fact that my laser scene had a move component in it, but no stats component in it. Since I converted the move component's code to require a stats component when the game ran, the move component on the laser scene didn't have a speed variable to work with and crashed the game. Yep, I am stupid.
I am stupid.
Moving on, now that the laser problem was dealt with, it was time to actually make them do something when they collide with the enemies. Since the laser is an area 2D, it has this area entered signal that fires whenever it enters the collision shape of another area node. And here is the function I connected that signal to. First, the code checks whether it is colliding with something and inherits from the enemy class, then it attempts to find a health component inside the colliding entity's scene tree, and if it does, it calls its take damage function, passing the laser's damage number into it. There is also another way the enemies can be destroyed, when it crashes into the player. When it does so, however, it destroys them both. Obviously, putting this function into each enemy type's script would be a waste of time writing the same thing over and over again. So instead, I placed it in the enemy class's script. Since all inherited from enemy have the area 2D's body's entered signal, all the enemies I make will have access to this function and execute it when the signal is fired. However, quick side note, for some reason I can't connect the signals via code, I have to do it manually each time in the inspector. Bit strange, but that's how Godot works for this, I guess. Day 6. Today was going to be productive. Today I would streamline my game's code. Now that the basic functionality of the game was done, I can make the code more efficient for later expansion. To start, I created a base laser class, extending it into separate subclasses for the player's lasers and the enemy's lasers. This makes sure that the player won't die to their own lasers and vice versa with the enemies. Now all lasers, as per the main laser class, will possess a move component, a stat component, a damage variable, and a function that destroys the laser when it moves off the screen via the visible on-screen notifier 2D node. The class for player lasers has a function that only runs if the laser collides with an area 2D that extends from the enemy class and then runs its health component's take damage function just like it did before. And the class for enemy lasers has the same code, just searching for players instead. I didn't stop with this classification of my code just yet though. Like I said, I wanted to add more than one antivirus ship to play as, so this calls for the creation of a player class. Now each ship that inherits from the player class will possess a health component, a stats component, a timer node for the firing rate, cooldown variable as I explained earlier, and a function that resets it when the timer runs out. This coding practice saves me a lot of coding time. Bearing in mind that I have only just started, converting the player's code from one big script to a class-based system saves 6 lines of code, not counting the space between the functions and variables. Also, this approach allows me to save on the game's file size. Let me explain. A neat quirk of Godot's class system is that each new class you create can be instantiated as a node. Therefore, instead of creating new scripts for each laser type, if I don't need any more functionality from them, I can just create the new laser scene and choose either player laser or enemy laser as its base node, and all the functionality from that class will work with that new laser scene. Sure, it's only a few bytes of memory, but if I start practicing these coding disciplines, it will work wonders when I create bigger games, especially 3D ones with large worlds that hold much more data than 2D games. Every little helps. And finally, day 7. To complete the first week of work, I decided to finish the final conversion process. Today, I will convert the large main player script into a state machine. This way, I can code multiple different behaviors for the player without having to keep track of multiple if statements, variables and the like. Instead, using more manageable bite-sized chunks of code. But first, I suppose I owe you, who are not informed, an explanation. So, what is a state machine? A state machine is a collection of multiple program scripts that determine the behavior of a player or AI. It is built up of separate states which are all created so that the player can behave in a certain way. The state machine keeps track of what state the player should be in, and handles entering that state and leaving whatever state they were in previously. Some examples of states would be a walking state, a running state, and a jumping state. I understand that might sound complicated to some of you who don't have any programming experience, so I prepared something to help you understand this concept a bit better. Think of a state machine like this. As you can see, we have this electric circuit diagram. We have the battery, or the player's input, we have the controlling state machine in the middle, and the example states I just mentioned on the right being represented by light bulbs. If the player presses a key to move forward, electricity runs through the wire, into the machine, and out into the walking light bulb. However, if the player presses the movement keys while holding the run key, then the electricity to the walking state will be cut off and instead flow into the running state. If the player presses the jump key, then only the jumping state gets power. In actual practice, the state machine only allows the code in one state to run at a time, locking the player into that specific behaviour based on what they are telling the game they want to do. Get it now? No? Well, using this architecture, I created two states for the player. Arcade chips don't really have a lot of complex behaviours, so I only needed two. The enemies will need more as they get more complex, so this is future-proofing. The first state I created I called the acting state, which was empty. That's right, no code whatsoever. What's the point of this? I'm glad you asked. Cutscenes. Obviously when you're running a cutscene you don't want the player to be moving around and shooting. The acting state therefore is used to cut off the player's ability to do so, only returning it by exiting that state once the cutscene is finished. The second state I created was the arcade ship controller. A bit confusing of a name, but I couldn't think of what else to call it. You may think of this as redundant code, and for the time being, it is, but what you fail to realise is that this is only the starting ship. Some other ships I create in the future could have more complex behaviour, such as the spinning tack, breaking down into smaller ships, shrinking and growing. The possibilities are endless. And that's all for week 1 of the development for Antivirus. While my work ethic isn't really the best in the world, I'm quite happy with the progress I've made thus far. Once this video is done, it's back to work recording further development. If you enjoyed, leave a like, press this funny button if you want to see more, and leave a comment if you are so inclined. All I have to say now is thank you for watching, and I will see you lads and ladies in the next one.